Hi everyone, and welcome to the project walkthrough session. In the previous session, we explained what the project is that you're going to attempt, and I would encourage you to take a first stab at it. But if you are stuck or if you need help with some of the steps, then please refer to this video and the subsequent videos where we will walk through the actual project notebook. In the downloaded material that you have for this particular course, you will see that there are multiple files. The two files that I would point your attention to is the one which is called LLM course lecture. This is an IPython notebook that contains all the code that we discussed during that earlier session where we were talking about token traversal techniques. So this is something you can play around with and see the results that I showed you during the video. The project that we are going to look at today, or the notebook that we're going to look at today, is called the LLM course project. And again, both of these are IPython notebooks. And the way we run IPython notebooks is by making use of the Google Colab environment. Google Colab is an online service that allows you to run Jupyter notebooks, and it really eases a lot of the troubles with getting started. You don't need to worry about running things on your machine. This is all running in the cloud, and it's running in a nice Jupyter notebook environment, which allows us to make a mix of both the code and the instructions, which is what you will see. So this is what I recommend to really get a very nice start and have a pleasant experience trying to complete the project, because that's our objective here. How do we get started with it? So all you need to do is go to Google Colab. So you can either Google for it and it will take you to the Colab link. This is basically, you can read more about the Google Colab. It's an online environment which provides you with access to a lot of virtual machines, including GPUs. And then that's what we will use in order to run our notebooks, although we don't need to make use of GPUs itself. So you can just click on this Open Colab link. This should open up this sort of an environment for you where you have various ways in order to upload your notebook. In this particular case, I hope you have downloaded the file, so you can just go here and then drag and drop the project notebook here itself, or browse to the file locally. It will just take a few seconds to load it up, and then it will present to you the entire notebook, which is the project that we are going to attempt in this course, Narrative Tales. Before we get into the project itself, just to give you a bit of pointers on how to navigate this. So what you see here is this left pane. It may or may not open for you. If it's not open already, you can just click this and you can see the table of contents. So this shows you all the steps that are part of this notebook. It allows you to easily navigate. So let's say as you work through the notebook, you have to stop and take a pause and come back to it. Then you can use this to kind of, navigate to the different sections. For instance, this is the summarization section. But if I want to go back to the start, then you can click here. So that's a nice, easy way to navigate. You will also see that there are at certain points that I have marked as learner tasks. So these are the specific points where you need to take some action. But what I would recommend you to do is work through this notebook in a step-by-step fashion. And when you see that, you will see that there is, of course, text. So I have explained what the project is about, what the objective is. So this is really like a textbook. But at the same time, it also mixes code in here, as you can see. So these are installing some Python project dependencies. If I pick up the first task, for instance, this is where we are going to load our PDF. So what I'm saying is this is a nice environment in which I can mix the instructions and the text, which allow you to understand what is happening and then execute it right there, so you can see the results of that execution. And this I find to be a very, very nice and pleasant learning experience. This may not be the way I would recommend you to write production code when you are done and have your product ready, but as a course and as a learning companion, I find this extremely good. So what we're going to do in the project walkthrough is go from the top to the bottom, and through each step I will show you how I execute it, what are the parameters to set, what are the prompts to add, and hopefully this gives you some hints and tips on how to do this yourself. I won't read through each and every step because that's something that you can do, but I will cover the most important aspects. You can see that the entire project is divided into multiple steps, including setup, reading the PDF, and so on. This is what I already explained in the introduction video, and now we're just going to walk through each of these steps. The first thing is to install the dependencies. In order to run any cell in Colab, all you need to do is press the play button that you will see against each cell. This is applicable only for code cells. So the code cells look a bit different from text cells. So something like this, which is installing project dependencies, is what we would call a text or a markdown cell. So this is where you're trying to explain something, add some text, add some images, and things that look with a slightly different background. For instance, this cell is what is called as a code cell, which is what is actually used to actually execute code. In this case, what we are doing is installing all the dependencies. These are Python packages that we are going to use in the course of this notebook. And each of these code cells will always have a play button, which you can then hit in order to run the code in that particular cell. And as it is running, you will see that a stop button shows up, which is if you want to interrupt execution, then that's what you would press and stuff like this. So what is happening now is you're running this particular bunch of code on a virtual machine which is running in Google's cloud. You can actually get confirmation of what this machine looks like by clicking on the top right here. You can see, for instance, what are the resources that are being used. So this is your actual machine. This machine has about 12 GB of RAM, has about 100 gigs of hard disk, and so on. So it's a virtual machine running in the cloud environment on which you're running all your code and this particular notebook. Of course, you can do this locally as well, but running this in a web browser and using a virtual machine makes things way easier to get started. And that's what we're trying to do. This code has run. So once it has run, you will also see the tick mark here. So that means your execution is complete. If you face any errors, then that error will also be shown up in this. So the cell below the code cell is where you will see the progress of the code as you are, or once it has been executed, right? So that's a very quick introduction to what the Colab environment looks like and how do you run and work with the Colab environment. We've now run the dependencies. Our next step is to actually import the PDF. Right? So if you think back to our project, what we're trying to say is we take any input which is in the form of a PDF and create a podcast out of it. So that's what we're trying to do here. There are several ways in which you can upload the PDF to this. And the best way is what we have shown here with the screenshot. And that's basically based on this left pane. So there are multiple aspects of this left pane that you see here. This particular one with the folder is where you see files. So files that you can upload and then read into your notebook and make use of it. But what PDF to choose? In my case, let's go with something that has happened recently, which is like the antitrust lawsuit. So let's say the Department of Justice has a lawsuit against Apple. And these are some news articles about it, but this is an article on the Department of Justice website itself. So you can see that they give you a brief explanation of what it is, but I'm more interested in getting into the details, what really happened, what is part of this complaint. And that is explained in this PDF file. As you can see, it's about 88 pages long. So it's really a long PDF, and you can see the complaint and so on. So it has a lot of text. It's 80 pages of text, and that's very, very hard to get into. So in this particular walkthrough, I'm going to create a podcast for or based on this PDF, right? So what you would do is you would then download this PDF. You can then save it where you like, and then you need to upload it over here. You can again just drag and drop it as I'm going to do, or you can choose where to choose the file and then kind of upload it. Just remember that this is going to be a temporary environment, so it's not something that is persistent. If you don't come back to this VM, or if you're inactive for a long time, then this kind of goes away, and so does the uploaded file that you have done. So that's kind of what this warning is telling you. But for now, as long as you're in the environment, as long as you're executing the notebook, this is already there and you can work through it. We've now uploaded the file, but now we have to read it in programmatically, right? That's what we are going to look at here. And this is why I call this the learner task, because it depends on how you want to upload the file, right? So you can use it locally. You can also use it from a given URL, right? So I could also just directly create this URL and then read that in there. That's really up to you. I have commented out this section of code. So if you're going to read it from a URL, then you can use this. Instead, if you're doing it like me, like reading it from a local file, then then you can use this. What you would do is copy the path of this particular file and replace this with that. And then again, as I said, click the play button. Here we are making use of a library which is called PyPDF. That's a Python library that we are going to use in order to read this. And you can see that I'm printing the number of pages, which is 88 in this particular case. So I have read the PDF, right? So it's pretty easy and straightforward. We can also make sure that the PDF has been read correctly, so we can decide which pages we want to go through. So for in this case, I have chosen to read the pages from 11 to 30. This can also be, I don't know, from pages 2 to 30, for instance, because you saw that the first page had a bit more tables and stuff like this, so not really necessary information. So let's just go through the first 30 pages, let's say roughly the half of it, and then you can see what the document says, document 1 file, and then it says page 3, Apple 1 Parkway, who's the defendant, and stuff like that. So you can see that this is kind of correctly read the information from the PDF. There's a lot more information there, so you can expand it and so on. It fills up your screen, so you can also clear it using this option. The next and most important thing, so what we've done now is we're setting it up, right? We're setting up the projects for this. We have installed the necessary libraries. We have uploaded the PDF file to the Colab environment. The next and most important thing is setting up the OpenAI API key. I provided a lot of instructions here, but essentially what you need to do is go to the URL called platform.openai.com, right? So this is different from chat.openai.com or which is also now redirecting to chatgpt.com. This is the web version of ChatGPT, also very good, also recommend you to sign up for it. But this is not what we are going to do in this project, because we are going to use the APIs that OpenAI provides in order to build our own product. And that's why you need to go to platform.openai.com. By default, it will open up the developer platform with the documents and the API reference and so on. But let's just say if you don't have an account, then you please sign up. I already have an account, so you can log in. I've chosen to log in with my Google account, and then you will be presented with even more options. So of course, the docs loads up, but you also see options like playground and dashboard. And what we're interested in doing is hitting the dashboard. And now is where you need to create the API key. Typically, you can create different projects here. So there are different projects that I work on, and I try to separate the API keys that I use based on each project. So let's say I create a new project and I call this the LLM course, just to help me remember and identify it. So that's the LLM course. I create a new project for it. Once I've created a new project, it will then drop you directly into this dashboard where you can sort of play around with a lot of the options, right? So the OpenAI API, there isn't just one. There's really a lot of things. You can do something called as assistance, you can do fine tuning, you can do patches, etc., etc. So there's really a lot that you can explore. But again, we are trying to take a particular path. So what we are interested in doing here is the API keys. So we click on API keys here. You can see that there isn't any API key at the moment. So what you can do is create a new secret key. You can call it something. So like you can say LLM course project, for instance. So this is the API key. It's something for you to remember, right? So this is the project, and then this is the specific API key that you're using for this particular project. And maybe let's just add Colab, because we are going to use it in the Colab environment. Then you hit create secret key. Now, please note that this is the only time that you will actually be able to see and copy this secret key. It's very important that this secret key is not exposed. So you can copy it. The moment you copy it, make sure that you're not overwriting the copy. So you've got now this new API key, as you see here. And then you go back to your Colab environment. Again, you make use of the left-hand page, but you see this secrets option now, and here you need to create a new secret. So in this case, for instance, I'm creating a new secret. I can call this secret the OpenAI API key, and then I would paste in the value here that you copied, and then make sure that it is hidden. So the moment you click out of it, this is already there for me, so that's the case why it doesn't work, but this is kind of what you will see here. So this is where you paste in the API key, and then you can also click this button to enable or to allow this notebook to access this API key. There are several other API keys that I have added here. As you can see, this is not necessary for you, but this is a nice way to manage the secrets while still working in your Colab environment. Do make sure that you are not exposing this API key to anyone, because if anybody else has this API key, they can start calling the OpenAI API and you will be incurring costs for this. I have shown you this, but of course, after this video is published, I'm going to delete that particular API key. How much does it cost? So by default, if you sign up for an OpenAI account, you will get $5 of free credits, which is a lot. And for doing this project, you will roughly need about 60 cents in order. And if you the text part of it is actually very, very small. It will be even of the order of a few cents. The voice aspect, which is the last step that you will see here, which is generating the actual MP3 file, is probably the one that will turn out to be much more expensive. But other than that, I think you should be very, very done easily with just the $5 of free credit that you get when you create a new OpenAI API account. So we've now set up the OpenAI API key. So this is completing all the setup that we have done. And then you need to also provide this notebook with access to this. And so you initialize the OpenAI API with this. So we are importing the OpenAI client. So this is how you do it. And then you pass in the API key using userdata.getOpenAI API key. This is the one that is reading from the secrets file in the Colab environment. Right, so our setup is done. Now let's get into the actual project itself. So the first thing that we want to do is read in the PDF and kind of start manipulating with it and use the LLM to summarize it. But before we actually do this, we need to understand an important concept of tokens and context window. Now, I talked about tokens a lot in the earlier video, and I always tried to say there that you can think of token being analogous to word, but I also said I will explain this a bit better, and this is the point where I explain it with the help of an example, right? So what we are going to do here is kind of do a tokenization of an existing sentence, right? So I'm taking the case here of a sentence which says Gumroad is a cool product, right? It's just any sentence, you can pick whatever you want, and then I'm generating how this appears to the LLM. So what are the tokens that are associated with this? And you will see when you run this code that this happens to break down this entire sentence into multiple tokens. And these are the tokens that it has broken it up into. For instance, you see that the word Gumroad has actually been broken down into 3 tokens and not 1. Which is how it would have been if it was a word, right? So that's why I said that the token is not equal to the word. So the tokens in this case is G, and road, right? So these are actually the tokens into which Gumroad is broken into. But on the contrary, is a cool product is actually its own words or its own tokens, right? So is a cool product are all their own word, and in this case word is equal to token, and then you have this exclamation mark which is its own token. So this is just to kind of say, and you can also then change this, right? So you can say, for instance, I just want to use my name. I can say Siddharth, and then the tokens will change. And you can see, or the way my name is broken up now is also different, etc., etc. And this may not be always the case. So if I use a more generic name like Tom, then this may not actually get broken into multiple tokens. It might actually be just one token, as you see here. So what I'm trying to say here is that the token is not always equal to the word. This is a choice that is made by the LLM provider. In this case, this is based on the choice that OpenAI has made. And if you use a different LLM, you can get a different tokenizer, and they may tokenize it in a different way. So that's just a choice that they make based on several design reasoning and so on behind it. In the end, it doesn't really matter how they choose to do it as long as the performance of their API is good. Where it matters is because the cost of an LLM call is based on the number of tokens that are there in your prompt. So the prompt that you send and the prompt or the response that you get back, the cost of this LLM call is measured based on the tokens that are there in both the input prompt and the output prompt. And that's why it's important to recognize this and understand this. That's the first reason. The second reason is because of something called as a context window. A context window is basically the amount of tokens that can can fit in a single LLM call or an API call to the LLM. When LLMs were first started, these calls were, or these context windows were very, very small, for instance, 4096 tokens. And then over time it has increased. So now I would say 32,000 tokens is quite a standard. 128,000 tokens is also quite common. For example, GPT-4o mini, which we will use now, has a context window of 128,000 tokens. There are also models out there which have up to 1 million tokens. So there's really a lot that has developed in just the last year. But it's important that because you are charged based on the tokens, the cost of the LLM API and the call is also based on the number of tokens that you send to it. That's the first part. The second part of it is that, of course, you can put a lot and fill in the context window. So you can say, hey, let me take this entire PDF, which is 88 pages, and send that entire PDF to the LLM API. It will fit in the context window because the context window goes up to 128,000 tokens. That's already a lot. And the problem might be that because you have now sent so much information, the LLM may not know or may not pay the same attention to each part or each aspect of what you've sent in the context window. It might focus a lot more on the words or the tokens that come in the beginning and in the end of the context window, and not pay as much attention to the tokens that come in the middle. What does that mean? It means that when it generates the summary or the highlights, it actually generates a lot of points from the beginning of the document and the end of the document, but not necessarily from the middle of the document. This again, behavior is different. It is not deterministic. You cannot say for sure that this is how it will happen. But these are some of the points that you need to remember and consider when you are thinking about the context window and how to manage the context window. So what I typically encourage folks to do is to not use the entire context window, but to use a reasonable aspect or part of the context window, which means that I don't send in the entire PDF in one shot, but rather break up the PDF into individual elements. You can think of maybe a couple of pages, maybe a couple of paragraphs. This really depends on the use case that you're dealing with, so that the LLM has full attention or concentration on that piece of text and generates all the output based on that piece of text. So you get a very good coverage when you do it in this way. But of course, the downside of this is that you cannot just send in all the text. You need to take some effort to split this text into multiple aspects, and then that's what we're going to do in the next step, right? So this is where we need to chunk our entire text into different kinds of components or parts. Why do we do this? For example, how much is the context window of this entire corpus, right? So we've taken this PDF. Actually, we've only considered the first 30 pages. So for instance, this is the input text. You can see we have read the input text from here. This is the input text. That's what we saw earlier. But let's suppose that we go in here and take all the pages, right? So we take the pages starting from page number 2 right till the end. So that's going to be really a lot of text. And if you now look at how big is the amount of tokens in this particular one, so you can see number of tokens here. And you can see that this is 36,000 tokens. That's a lot of tokens, but if you remember, the GPT-4o mini has a context window up to 128,000. And you might say, okay, why don't we just use these entire things, send it everything in one? But this is where the attention problem comes in. And therefore, I would recommend that we split it up into multiple chunks and then send smaller pieces of this to the LLM, so that the LLM is summarizing each aspect separately and not kind of looking at the entire document as a whole. And that's kind of what I would recommend, but it's really something that you can play around with. So what do we do then is we have to split the entire text into chunks. And for that, we use or we make use of NLTK. It's a natural language toolkit, which is a different library. We use this to break it up into sentences, right? So when you are now chunking it up, you don't want to cut a sentence in the middle and then send it to the LLM, because that will not have much impact. So we try to at least break it into sentences. And then once you break it into sentences, then we have defined a function called as chunks. So create chunks, and these chunks basically split the entire document into smaller pieces with a certain max token length, right? So in this case, I have specified a default value of the token length to be 2000. but this is a parameter that you can change. And what this method is doing is basically iterating through the entire text, first splitting it into sentences, and then splitting it based on the number of chunks. So if it reaches 2000 tokens in the first chunk, it would say, okay, this is my first chunk, and then move on to the next one. So that's kind of what it is doing here. And then it's up to you now whether here you want to specify 2000, but maybe I specify as 4000 just to make the entire chunk bit bigger. And so what you will see now is that you have created 10 chunks. So the entire 88 page PDF that you had is broken up into 10 chunks, and then you can see what the value of each chunk looks like. So that's kind of all of the information. It's very hard to read even now here, and that's the reason why you would use the LLM for it. So what we have done, till now we have done all the setup. So set up the OpenAI API key, uploaded the PDF, added the tokenization aspect. So we have split the entire PDF into multiple chunks, 10 chunks to be precise. And now we finally make the call to the LLM. And this is the call where we are going to summarize the PDF. Of course, now you're coming to the prompting part of it. So we have to now here prompt the LLM to kind of do the summarization aspect. If you remember, we said, let's break it down. This is how you would think as a human being trying to create a podcast out of this particular document. You would actually read through this document, summarize it, and so on. And now we need to translate that into a prompt, which we would then send to the LLM. Let's try with some prompt. And here I take you back to the prompt framework that we spoke about. And let's say this is kind of how I want to think about creating my prompt, right? So I would say, hey, you are a podcast researcher. So I'm giving it the persona who is good at reading through multiple documents and text on a particular topic and highlighting the necessary, my spelling is really horrible today, highlighting the necessary aspects that would be covered in the podcast discussion. So that's the persona. Then you have to give it the task. So you will be provided with a piece of text that has information about a particular topic. You can also say about the Department of Justice lawsuit against Apple, but that would then make it very specific. So this is where you have to figure out how generic you want it to be, how specific do you want it to be. Anyway, so this is the task. You will be provided with a piece of text that has information about a particular topic. You have to identify the most important highlights and key points in this text. So that's the task. I also want to specify an output format. So you will return the highlighted aspects and key points in the following format. And here I'm actually going to give it an example now, as you see. So let's say highlight one about the topic. Then you would have highlight 2 about the topic, and then you would have highlight 3 about the topic, right? So what I'm saying is I'm following the prompt framework that we discussed. I gave it a persona, I gave it a task, and I also gave it a output format. I wanted to return the highlights to me in this particular way. So that's my instruct prompt, and you can hit the play button. So that's the prompt that is going to then be used. We are now making the LLM call, but as you can see, we have already chunked the PDF into 10 different chunks. So there are going to be 10 different such calls, and to each call you want to add the same instruct prompt because you have just broken up into multiple pages, and for each set of pages you want to find the highlights and stuff like that. So that's kind of what we are doing here. This is how we are going to make the call to the API to OpenAI API itself. So this is the chat outputs. Then you say, hey, for every request in these request messages. I'm going to make a call to the chat completions API. I give it the roles. There is something called as a system role and there is a user role. This is how you make a call to the OpenAI API, and this is called as a system prompt. So this is something that is a persona, or you can also make a change here to say you are a podcast researcher. You can actually add that here, so you can make it in a system prompt, and this is the user prompt. In general, there isn't as much distinction between the system prompt and the user prompt. This comes into play a lot more when you have a series of conversations, because then the system prompt is the first prompt and every subsequent user message will still keep the system prompt in memory or in mind. Whereas what we are doing here is kind of making individual calls. So therefore, there isn't much of a distinction between the system call, putting something in the system prompt versus putting it in the user prompt. But if you are sort of building a chat application where you want the chatbot to behave in a certain way throughout the entire conversation, then that instruction is something that you would put in the system prompt, right? So that's the distinction between this. When I now do this, what is happening is it is iterating through all the requests, and then for each request making the call to the OpenAI LLM. So this is actually going to go through it 10 times because we have 10 chunks, make 10 calls to the OpenAI API in a loop, and then it will finish. And then I kind of just aggregate all of them. The responses will always come back in the content field from the chat response. So you can play around with chat response, but I have already provided all of this for you. And then I'm just aggregating all of it to create the podcast facts. And then if you look at the podcast facts now, this is what you see, right? So let me just expand it a bit. You get a lot of information. And you start seeing the summary. So it says Apple has a history of anti-competitive practices aimed at locking in both developers and users, making it difficult to retain them. That's the first highlight. And you can see it has followed this format that I asked it to do before. It has also then given the next highlight in the next way. So kind of saying, hey, this is the next line and this is the dash that I wanted it to do. And then this is the company's dominant position and so on, right? So you can see that all the podcast facts, and now you can see it's really quite a lot. So these are all the ones. It's quite small actually. It has compressed the 88-page PDF into this small aspect, and these are the highlights that we can then take into the next step where we are going to generate the podcast conversation itself. I will do that in the next video.